This video is brought to you by Sportland, quality, integrity, and tradition. So we've got a call on an AC not working for this area over here, but where I'm starting at is investigating the return, because oftentimes this one has a ceiling return. Those things can be plugged up and really dirty. It doesn't look to be, but the louvers are also going up, so it's kind of hard to see up there. But to me, it doesn't look that bad. It looks like someone recently brushed it. And someone also recently just painted all these ducts. So the next thing I'm looking at, because they just did a remodel here, before I even go on the roof, is making sure that like dampers aren't shut and stuff. So this one's in an odd location because the return is in a different room than the room that this feeds in. So if you come over here, this goes through this wall over here. And man, those are some massive supply ducts for this guy. This is just like a 7.5, maybe a 10 ton. But the dampers don't look closed. They have butterfly dampers in them. So I'm just going to investigate all those, and then we'll get up onto the roof. All right, well, this is our unit. It's early in the morning. It's about 8 a.m. right now. So heat is actually running for the whole building. So we are going to have to put this into a call for cool. This particular customer has like an internet controlled thermostat system that I do have access to, but I don't really care for it. It's a Bayweb system. It's not my favorite. But I recently just went through and had to do, I basically got into the system. It took me, I had to pull teeth to get access to the system. But once they gave me a login credentials, I went through and reprogrammed their entire setup because they didn't have it in auto changeover, which we were running into a lot of heating problems here. They would constantly call me and say, it's too hot, it's too cold, it's too hot, it's too cold. And then I reprogrammed the system, set up a good schedule, and put it in auto changeover. Which bay controls, y'all are ridiculous on your tech support, because I called them. This was a couple weeks ago. This has nothing to do with this call, I don't think, but I called them for tech support because I didn't know how to navigate their system. So I was like, hey, let's get someone to help me walk me through this. And I was on hold for like half an hour. Finally, they said they'd call me back, and I never got a call back. Well, I kid you not, it was like a week later that they called me, just out of the blue. They're like, yeah, this is so-and-so from Bay Controls. We're calling you back. And I'm like, yeah, that was like a week and a half ago, bro. I already got it figured out. So that was pretty ridiculous. But anyways, to the task at hand, I'm going to have to log in, put this system into cooling, and then see if we find anything wrong with it. I made a video on this unit last summer where the top of the compressor was so hot. The water was evaporating when it dripped off of the plugged up, what was it? I think it was the liquid line was iced up, and it was dripping on there. And the liquid line was iced up because the filter dryer was plugged up, if I remember right. And that's why we got that guy right there. But, all right, don't really see anything too crazy in here. Nothing too crazy. The contactors don't look the greatest, but nothing scaring me too much. This also goes to show you, if you didn't know, these copper straps, you can buy this copper plumbing tape. It's not copper, it's just like a copper coated tin or something. That's why it's rusting like that. But that's fine. All right, well, let's let me log into the thermostat system and see what I can figure out on that. So nothing too crazy going on here. We're looking at, on the left is the date. Let's see. On the far left, the first column, that's the temperature in the building. The second column is the set points. And then the third column is the outdoor temperatures. So all our units are calling for heat except for the two bottom ones. Those are the kitchen units. They actually aren't on the system anymore, so that's why they're yellow. They're controlled with conventional thermostats. So everything else is still on the Bayweb control. So I don't see anything too crazy. Over here, these numbers, they're doing some other stuff. They're sensing water heaters. And then they also have walk-in temperature sensors for the cooler and the freezer. So freezer's -3, cooler's 35. I'm assuming the water heaters are 135 and 110 maybe. But yeah, anyways. All right, well, I'm gonna give us a call for cooling and see what happens. It's gonna suck though, because we have a really low load in the building, so it's gonna be kind of wonky, but we'll at least see if the system comes on, what happens. It just dawned on me, maybe you guys saw it and I didn't. I just switched the system over, okay? So the second column down is the AC that I'm working on. I set it for 50 degrees, but it's 71 in there. It's set for 68 and the heat was still running. So there's something going on here, because the heat shouldn't have been running if it was 71 degrees in the building. So something's going on with this thermostat, I think. Never mind, that was me being silly. The second one down is not this AC, it's the third one down. So it's 67 degrees. I just switched it over, so it actually just shut off. I was thinking that the AC2 was this unit, but this is AC3. So it's 66 degrees in the dining room. So it was calling for heat, which it should have. So I switched it over to cool and 50 degrees, so that way will give us a call. Now this unit also has an economizer, so we need to run over to the economizer and see what's going on with that. If we come over here, let's go from common to W1. We no longer have a cool for heat. Common to Y1. We have a 24 volt call, so that's cooling, stage 1. Stage 2 is not calling yet because there's going to be a delay in the thermostat. So now we're going to go over to the economizer and see what the economizer has to say. It should be opening up right now. Filters certainly don't look great. Economizer's right here, so I'm going to loosen it from the wall so we can see it over here. See what's going on. But the cooling actually just turned on, at least for the first stage compressor. Second stage is not running. First stage is running. Warm discharge line. Cool suction line. Both condenser fan motors running. Now, normally you don't want to leave this open, so we're going to put this panel up here a little bit, but it's really cool outside, so it's not going to create a huge problem at the moment. Once we get to diagnosing and testing pressures and stuff, we'll need the panel on completely. And it looks like I have written right here that this is an 8.5 ton, not a 10 ton. All right, this is a Honeywell Jade controller, and we're gonna go through and see what we can figure out what's going on here. So I'm in status mode, so we can see everything. So let's go back up to the top. Okay. Y1, it's got a call, and it's sending the call to the compressors. Y2, it says it's on, but it's not sending the call. So what it's doing is it's economizing, but it's also using mechanical cooling. So first stage compressor's running, second stage is not, because the damper should be opened up, okay? So, and it's trying to satisfy the building using that, and then if it doesn't satisfy within a certain time period, then it'll turn on second stage cooling. Mixed air temperature is 55 degrees. Outside air temperature is 54. Damper's open 100% according to the controller. Okay. Don't really think I need too much more than that. Let's go back. Let's go to set points and see what temperature we're set up to economize at. It's got a lockout at 32 degrees. Dry bulb set point is 60 degrees, so it's not going to economize unless it gets below 60 degrees. I think that's pretty fair. You want to have a temperature differential between the building, so you don't want to set that up to like 70 degrees. You want it to be 10-15 degrees below the building temperature potentially, because if you just set it up to economize at, let's just say 70 degrees, well, when it calls for cooling, it's only going to bring in outside air, and there's not going to be a huge temperature differential, so it's going to take a long time to cool down the space. Being that we have people in this building, in this area over here, they can probably fit like 60 people. You know, that's a lot of body heat, and you don't want to just be bringing in 70 degree air. 60 degrees, to be honest with you, might even be a tad on the high side for those reasons. We might even bump that down to maybe 55 degrees. And there goes that second stage compressor just kicked in. So we might bump that actually down to 50 degrees. Let's go 50, because then they're truly going to get a good heat transfer and bring the temperature of the building down. So now it's not going to economize till it gets below 50 degrees. We're going to try that and see what that does, but we still don't even know if the unit's working right, okay? I just heard the second stage turn on. Let's go over here and Second stage is running. Discharge line is getting warm. It's not hot, but it's getting warm for sure. So we're gonna let it run for a few minutes and then we'll probe up on the system. Well, I see a problem. I went ahead and put the unit into a test mode where it forces the dampers open. So it's been in test mode and it says damper open and it's running. My damper is 100% shut. We might have a bad actuator motor. We need to get in here and check some voltages, because if that's the case, then it could have been when they called this weekend, because it's a Monday right now, they called over the weekend, it said that it was hot in the dining room. Well, if it was trying to economize and it wasn't pulling the outside air, you know, that could have been something going on. And then eventually mechanical cooling would have turned on. So this might not be our whole problem, but that damper should be open right now, and it's not. It should be bringing fresh air in through here, and it should be closing down this damper, and it's not whatsoever. My actuator has 26 volts going to it right now. So interesting. Oh, there it goes, there it goes. Now it's going. What's going on here? It's turning. Oh, interesting, but it's not turning the linkage. Look at that. So it's closing right now. So it's going back to 0, but it's not turning the linkage. Oh, check that out. So we've got voltage, but notice how the shaft is spinning? It's not tight anymore. It's not grabbing the shaft, so it's not actually actuating the dampers. So we need to get in there and have a look at that. All right. It's a 10 millimeter. For whatever reason, they're using metric junk. Sorry to all my European viewers. I know you guys think metric's the best, but we're not used to it. And I realize it's pretty smart to use metric, but. All right, so now we're tightened. So I'm gonna actuate this guy again, and I wanna see if it'll actually open and close now, like it's supposed to. Look at that. Now it's actually turning and opening the dampers. Woohoo! So that works now. So we got that part fixed, but I still don't know that that's our only problem, because even if the damper wouldn't have opened and cooled the space, eventually it would have turned on mechanical cooling. I guess maybe it would have locked out second stage, and if they had a busy building, maybe it wouldn't have been enough, possibly. But we got that part fixed. So let me put this guy back together. The filters are dirty, but I don't know that they're plugged. So, oh, that's interesting that even though I have it set to max, it should be in test mode right now. It's like backing off. Oh, interesting. We're getting a freeze alarm too. I wonder why. It's not 32 degrees in here. Go back to status real quick. Economizer available, no. Economizing, no. Occupied, yes. Cool Y1 on. Cool Y2 or Y1 out on. Y2 on, Y2 out on. Mixed air temp is 45 degrees. I don't know about that mixed air temp. Outside air temp 54. Damper output 0%. Actuator position. Mechanical cooling on. So it went to its minimum. Well, it should be going to the minimum position, which should be 4.5 volts, somewhere in there. It's a 2 to 10 volt actuator. Huh, what's going on here? This guy should be pulling outside air. I'm gonna have to watch it for a minute. This guy might be acting wonky. These plugs will get corroded out as time goes on too on these things. I don't know, man. Those top filters are pretty darn dirty. I think we're gonna have to change filters. This particular customer stopped their maintenance program. They had us do a maintenance 2 months ago or something. I don't know, it's been a while. But it looks like we need new filters at a minimum on this AC. But this guy should be it shouldn't be closed all the way, and it is. Let's go through set points here. We should be having minimum outside air position. Set points. Mixed air temp is 53 degrees. Okay. Low lock 32 degrees. Dry bulb 50. Minimum position 4.3 volts. So this guy should be at a minimum opening up. Unless, yeah, something could be off. Let's go to set points and go to minimum position, and let's run that up. Maybe it's just out of calibration. Sometimes that can happen when you tighten the actuator like I did. You gotta be careful now that I think about it, because I could have tightened the actuator when it should have been at a minimum position. So 10 volts should open it all the way, but theoretically we could overturn the damper right now if that's the case. So let's see what happens here. Okay, 10 volts, change stored. Okay, so this guy should be opening right now because I set it up for minimum outside air position to be maximum. But we also don't want it to break itself. So let's see. This is interesting. So I can get it to open the damper in test mode, but during normal operation, it won't run the damper in a minimum occupied position. That's very, very interesting. What is going on here? Something is up. It might be a problem with the controller. And like I said, these guys have a lot of corrosion problems. Like this one right here, there's a lot of corrosion in there. That should be the communication. Theoretically, I believe that's the 2 to 10 volt signal for the actuator, because you got 4 wires going to the actuator. Or no, that's like the feedback signal or whatever. I don't know. That's interesting. Oh, see, look, it came back on. See, that's weird. I put it into test mode and then it pulls itself out of test mode. Like it was in test mode a minute ago and now it's not. I think there's something going on in this guy. I pulled the top of the actuator off just to see if there was anything funky going on in there. There's not. It doesn't look like there's any corrosion in there. Looks like a microprocessor in there. I don't see any problems. So I think, because I keep getting this freeze stat alarm too, and the freeze alarm should be at 32 degrees and we're not at 32 degrees. And it's weird because I erase the freeze alarm and then it just comes back. So if I go back to status, economizer available, economizing, occupied, Y1 is calling, it's sending power to the compressors, Y2 is calling, it's sending power to the compressors. Mixed air temperature is 43 degrees. So that's where you're getting your freeze alarm from, I believe. Outside air temperature is 56 degrees. There's nothing there. Okay, so let's go to set points then. Let's go set points and see what the freeze alarm set point is at. I believe low T-lock is where you get your freeze alarm. There's nothing there. So let's go to advanced settings. Mixed air, oh. Mixed air low setting is 45 degrees. That's where I think it's getting its freeze alarm. Freeze position closed. That might be why we're not opening on minimum, is because of that. I bet you that's it. So if I go here and change that to 32 degrees, I bet you my actuator will work again. Oh, 35 is as low as it lets me go. Okay. So now let's go to normal setting. That's weird though that in status it wouldn't tell you that. Economizer available, no, no, yes, on. Mixed air temp 43. Outside air temp, damper output 100%. It's opening. That was our problem. That was all that it was. Okay, so it's weird though, because in the set points right here, mixed air temp set point was 53 degrees, but in the advanced set points, that's interesting. So that was our problem. And the actuator's opening now. Okay, now next thing, I'm gonna go back and set that all right, because I don't think it's 45 degrees at that mixed air temperature sensor. So I need to verify that is accurate before we go any further. For some reason, I can't get Measure Quick to work, so I'm using the Fieldpiece app. And let's see, my outside air temperature is 60 degrees, and my mixed air temperature is 43. So this says outside air is 59, and that says 44. Those are accurate. So interesting though that in the advanced settings that the lockout would happen like that, because you'd still want to pull minimum outside air position. So anyways, whatever. So we set that, we set it all back to the way it's supposed to be. We know the sensors are accurate. This guy is now working correctly. We have a minimum outside air position right here. I was using that for the outside air temp. So that is accurate. So now we can go ahead and finish troubleshooting the unit, look at mechanical cooling, make sure that's all working. And then we got to dig in to make sure that we're reading the right sensors, because this has remote zone sensors for the thermostat system. And sometimes those can fail. Not saying that's what's going on here, but sometimes in some situations, some thermostats will have an auto changeover. If the remote zone sensor fails, it'll change to like the local zone sensor at the thermostat. And I've seen that where that causes weird problems before too. All these thermostats happen to be located in the office. So if this system is capable of doing the auto changeover between zone sensor and thermostat, sometimes if the zone sensor fails, and again, I said in the beginning, they're doing a bunch of construction in here, so I wouldn't be surprised if they didn't pull the zone sensor off the wall and screw everything up. So I need to look into that too. Interesting too, in the advanced settings, so mixed air low setting, I set to 35, right? I bottomed it out. If you go to the next step, it says freeze position, close the damper. You can actually change it to do it to minimum position. So I'm not gonna do that. I'm gonna leave it in the closed position, but that is an option too, is if it ever got below the 35 degrees, it would just, like it did, just close the damper and not let it open. So, I have to be honest, I've never read the manual on this thing. I've just kind of worked my way through the programming. So many of you guys are probably screaming at me saying, oh my gosh, it's so easy. But for me, again, I didn't read the manual. So that's a pretty common trend with me if you haven't noticed that. But okay, so now we're going to continue on. All right, so what I've done is I've confirmed that AC number 3 says it is 62 degrees inside of here right now. Currently set to 50. I've got probes in the office where the thermostats are, and I've got probes out here in the dining room. So let's go ahead and switch over and show you what we're actually reading. Well, the probes aren't reaching, but it was 68 degrees in the office. This probe right here is reading 62. So we're reading the occupied space temperature in the room. So I know the thermostat is not getting inaccurate readings. So we're good on that side. All right, I'm probed up with my pressure probes and temperature clamps. I'm having a problem with Measure Quick today, so I'm having to use the Fieldpiece app. But the Fieldpiece app isn't as user-friendly because it doesn't auto-calculate airflow and different things like that. So, but I had to there's some workarounds you can do. So we're connected, and before I evaluate the system pressures and temperatures, I need to tighten this belt, because I noticed when it was running that this guy was running a little bit loose. It's a decent looking belt. It just needs to be tightened. I shut the unit down. Pulley's looking good, feels good, no weird grooves. So we're definitely gonna get in here and tighten this guy up real quick, and then we'll finish with our evaluation. I gotta say, Measure Quick, you guys are killing it. So I was having a problem connecting on all my devices, and I reached out to Measure Quick through a Facebook page. There's a common Facebook group actually for Measure Quick. I think it's called Advanced Measure Quick Users. I put a post on there saying I was having problems with these devices. Measure Quick immediately responded with the answer with screenshots, and I was able to fix it. There's a new update in the Android platform, and it needed to allow permissions for nearby devices for Bluetooth. So that's what it was. So I'm assuming, by judging by this, because when you connect to the field piece probes, they're not paired with my tablet. They're looking for, the app itself is looking for it. So we had to set it up to allow that. It's a permission. So Measure Quick responded within 20 minutes of me posting that. And I'm gonna leave it up on the group, because then hopefully other people can get the answers to that too. So that was really cool. So now I'm able to profile it through Measure Quick. So I'm gonna redo everything. All right, I got the wrench I needed. I don't carry everything in my van. In my bag. A 5/8 wrench is not commonly used, so not with what I'm doing. Everybody's got to tailor what they carry in their bags to what they actually do. For me, the most common wrenches that I carry in my bag: 1/4, 5/16, 3/8, 7/16, 1/2 inch, 9/16. That's what I carry in my tool bag with me every day. And then I leave the big boy wrenches, the 5/8, 11/16, 3/4. I leave all those in my van. Then I have like sockets and stuff for big things. But okay, so what I loosened was these guys right here. Those guys. So now the whole blower assembly, the weight of the blower motor is pulling down on this nut. So all I got to do is loosen this guy, and it'll drop down and tighten up. Now there's only so much weight to that motor. I'll probably have to put a little tension on it myself, but for the most part, the belt's getting tighter. Now if I didn't have this zip tie on there, what I could do, well, a couple ways you can do it. You can use this nut on the bottom to force it down, but this nut on the top would have to be extremely loose. But I also have a zip tied to some other zip ties to kind of protect these wires, but the wires themselves are not touching the all thread because of the multiple zip ties that I used. Alright, so there we go. So now the top nut is free. The bottom one, I can put the tension on it, and as I tighten the bottom one and bring it up, it's going to force the entire blower assembly down. So there's a reason why this thing has double of the nuts on it. So that way you can actually tighten it. So belt's getting nice and snug. That's pretty good for my house. All right, so we are set up on Measure Quick. Everything's profiled the way it should be. I'm not seeing any problems. We're within the green for superheat and subcooling. This is a fixed orifice metering device with R22. Pressures seem to be on point. Oh, supply air temp's not right though. The heater had turned on for a minute, so I pulled my supply air probe out. Trust me from experience, they'll melt. So supply air temp should drop now. Let's go ahead and jump over to second stage and see what's going on there. All right, second stage, superheat's a little bit on the high side. So we're gonna let it run for a bit. But pressures are about where they should be. Superheat, being that it's a fixed orifice, is calling for about 5 degrees. But our subcooling is at 19. It's possible that we have a low charge issue, but we also might just need to let it run for a little bit longer. But low charge, the subcooling's kind of high. So if it is low on charge, then it would more than likely have a restriction, possibly. But let's just keep letting it run. Let's scroll on through. Supply air is 51, return air 70, so the temperature split's about 18 degrees, no big deal. It's estimating that airflow is about where it should be. We're a little bit low on the delivered capacity, but again, let's give it some more time. But I'm not seeing anything wrong majorly refrigeration wise. Like, everything looks okay on this. Now another thing I want to say too, there's nothing against the Field Piece app. I was saying that I prefer jumping over to Measure Quick. Measure Quick is just easier when it comes to, number one, it does an auto calculation for airflow, and I really appreciate that. Number two, Measure Quick is a little bit easier to get the system parameters or system measurements that you want, because, like, for instance, Measure Quick lets you get discharge temp. Field Piece probes don't, or the Field Piece app doesn't. The Field Piece app also doesn't let you use outside air, one of their probes for outside air, which, you know, I've brought this stuff to their attention, and I've been told that they are going to fix this stuff, so stay tuned on that. But I just prefer the Measure Quick app, especially if you're working on multiple circuit systems with multiple probes. I just prefer the user interface on Measure Quick a little bit better. All right, so I mean, this thing seems to be doing everything it's supposed to be doing. For the first stage, 4 degrees superheat, 20 degrees subcooling. Let's switch over to the second stage. Second stage, the superheat's still a little bit high, 17 degrees, and we're running about 18 degrees on subcooling. Now, something to understand on these carrier units, unless you add them, they use discharge pressure for the that's the only pressure port is discharge. You can't get a liquid line pressure port unless you add it to the system. I typically see something along the lines of a 35 psi pressure drop when I do add a liquid line pressure port. So that means that this number is typically going to be on the higher end. You see why it's like 18, 19 degrees. It tends to run high. If we had an actual pressure port on the liquid line, it would probably be a little bit closer to about 10 degrees, somewhere in there. Someone can do the math if you guys just look at the pressure differential. Now, granted, it's really cold outside too, so that's why we have such a low head pressure on the system. It's also a little difficult on these systems when we're running with such low indoor conditions and outdoor conditions. It's kind of hard to troubleshoot. So I think that we have a slight restriction on the second stage, judging by these pressures, and the pressures look okay, but the superheat's a little bit on the high side. So typically I'd like to add a little more refrigerant to the system, but you know what, just thought about something. Well, no, that should be fine. So I typically want to see that superheat a little bit lower, but with the subcooling of that level right there, it's indicating to me that we might be slightly starting to get restricted on the fixed orifice metering devices. I don't think it's a horrible issue. It's not the end of the world. If you have a massive restriction on the fixed orifice metering devices, then you can usually see it in here. When you look back in there, you can see it frosting up. I don't see any of that right now. But yeah, this is about all this unit's gonna do. I'm not concerned with the operation. I am gonna go ahead and change those contactors though. The contactors that were in pretty cruddy looking shape in here. Let me pull this off. Unit's still running, but I'm gonna go ahead and change these guys out, put 3 new contactors in there. That way we don't run into any problems come the summertime. So yeah, I mean, there's not really much more I'm gonna tell them about this air conditioner. I think that possibly their initial call had something to do with the economizer, trying to economize but not fully economizing because the damper was loose, and then also the settings were kind of wonky too. So I think that's where our problem lies. Other than that, I can't really see anything else besides preventative issues like these contactors. So I'm gonna swap those out. All right, we are gonna change all these contactors. They are all original OEM, I can tell by the look of them. Same thing with the switching relay for the condenser fan motors. We're gonna change that too. Based off of the age, based off the look on these ones, I bet you anything on the inside of this one, it's charred up too. Now granted, this one isn't open to the outside environment as much. It still does get some, but for the most part it's an enclosed setup. But still, we're gonna change that preventatively. Now, I don't have all the right contactors. These ones have screws, these ones have lugs. I just recently did a short on this, and I think I said it in another video too, but you can just simply take these lugs off and this will accept screws. I get a lot of people asking me, well, why not just cut the wires and put them into a lug connector? Well, you could do that, but I prefer to go back with what was in there. There's weird situations where maybe on some of these, maybe all the Maybe they got multiple wires, or who knows, you know? So I just like to put in what belongs on these units. So yeah, exactly that. There's multiple wires on this one screw connection here. So I'd rather not shove multiple wires in a lug. I'd rather put the screw connection on like that. So that's the exact situation. Because that I can tighten down and it'll work fine. And that's all OEM. So, you know, I just prefer to go back with what's supposed to be in there as much as possible, unless I really need to make a change. There's been times when I've cut the wires off when I don't have one and just put them in there. So I'm going to get to changing these things out real quick. Whenever you're doing contactors, you always want to make sure you take a picture, not of yourself. My camera was in selfie mode. Helps you just in case you miss something with the wiring. All right, now I got everything changed out, all the contactors. I looked at my pictures, made sure I wired it all correctly, changed the switching relay for the condenser fan motors. Everything is good to go. I'm getting my tools out of here, and then we're gonna fire it up and test fire everything to make sure I did it all right. All right, I turned power on, nothing blew up, so that's step one. Indoor blower motor turned on, that's a good sign. I should probably label these guys. What I'll do is I'll label them as we're going along. So we still got to put the panels back, or the screws back in that panel, but okay, so that's indoor blower motor, and then we just need to wait for all the other stages to come on. All right, it fired in heat, but I labeled them all. And so we know heating works, that's good. So now I'm gonna get into the internet thermostats and give us a full call for cool. All right, compressor number 1 just turned on. Comp number 1 contactor. I don't know what's going on. I got a police helicopter flying over me right now. Lovely. All right, so comp number 1, indoor blower motor's working. We're just waiting for comp number 2 to come on. The Economizer has a 5-minute delay on it to hold it out. So as soon as that comes on, then we'll be good to go. And that is comp number 1. I totally missed a wire, so I got to go through and I was across the roof and I heard this compressor turn on, and it was single phase, or it was running backwards. So I crossed the black and the yellow on the top. So even though I double checked myself, I didn't double check it right. So always watch the equipment turn on. So I shut the unit off, reversed the phase, and we're waiting for it to turn on again, but I got to go through and change the heat setting again. Second stage should be kicking on here any minute, but I would love the opportunity to replace this disconnect switch. Given the opportunity, we'll redo the electrical, make these wires come straight up here, run under here, then go in there, get rid of those wire nuts. And then also I'd love to get rid of all this, all the OEM pressure control wires. They run so much extra wire. I love to shorten them and make it nice, clean connections. But again, I'm not just gonna do everything, right? I'm doing what needs to be done, then I recommend to the customer. There goes that second compressor, and we are all good. So heat works, cooling works, we're good to go. I'm gonna log into the thermostat system, set all the settings back, and we're gonna tell them to keep an eye on it. But yeah, I'll bring to the customer's attention about the electrical, and we'll just tell them, like, you know, the only thing I could find really wrong was the Economizer settings. And I fixed that stuff, and without seeing the problem in action, I don't know what they were experiencing. I tried my best.
Sometimes it can be a little difficult to find the exact problem. That's why working your way through the equipment, at least that's the way I approach it, is just, okay, so I don't know what's going on, but we're just going to go through and troubleshoot the equipment. Just see what we find wrong. Sometimes you fix things that are not associated with the problem, but you know, you're there, it's like, okay, I'm going to fix this problem. I think that what was happening, we're in this weird, mild climate here in Southern California, okay? We have what we call cold weather, which the lowest it gets is maybe like 38 degrees, 35 degrees, something like that. And then we have high extremes. In the summertime, it can get 115, depending on what part of California, sometimes 120. Like, it's nuts how hot it can get. It's kind of difficult because we don't use heating as much as you would think we do, because when you have a building that's full of people, their body heat is going to heat up that building really quick. So I think that we're in this weird time where it's cool outside, so someone might walk into a restaurant that's not very busy and it might seem cold, but as the restaurant fills up with people, all of a sudden it'll warm up. I think that they had a big rush of people come into this building, and the area that they were complaining about is where they sent giant parties, okay? So I think that they brought in a giant party. The temperature in the room came up really quick, and it's possible that maybe the heater had turned on, but it just got too hot in there. And then what happened was, and I didn't explain this in the video, the customer explained to me that the patrons sitting at the table that were getting hot basically asked if they can open up the doors on the outside of the building because they have emergency exit doors. So then they told me that they opened up those emergency exit doors. And then what I think happened when they did that was when they opened that emergency exit door, the cold air rushed in and cooled off the zone sensor. And then the heater turned on. And then it made it even worse. Oftentimes, you just got to give it a few minutes to kind of let the system handle what it needs to do. Now, it's also possible that there was something going on within that economizer. Because again, picture the room fills up, it gets really warm really quick, and then all of a sudden, they open up the door, whatever. But when it tries to cool in that situation, it would have tried to go through all the logic in the economizers. It would have tried to open up first stage, open up the damper. Then the damper wasn't opening because the linkage was loose, right? So then we fixed that problem, but then we found that okay, now it's going to lock the damper closed because it was getting too cold in the eyes of the economizer. So I think that there was a couple things going on here. So the AC, all the compressors would have turned on eventually, even with the damper closed, but you've got a 5 to 10 minute period of all the steps that it has to go through before that can happen. So who knows exactly what happened here, but I definitely just went through and fixed what I could, evaluated the unit, tightened up the belt, fixed the linkage, fixed the programming of the economizer module. And it's also odd too that like one would think, well, that economizer, has been in operation for many, many years, right? But we're also having this weird weather right now in Southern California where it's colder than it has been in previous years. Also, I alluded to something. I just had to reprogram their energy management system to where they actually had heat automatically in the building, because previous to me doing that, someone would physically have to log into the thermostat system because of the way that it was programmed and set up and say, I want it to be in cooling or I want it to be in heating. So we've been getting a lot of nuisance calls from the customer saying, it's really cold in my dining room. Can you come out and fix it? And then I'd go out there and be like, and then I realized that the thermostat system wasn't set up right. So I reprogrammed all of that. I set the thermostat to maintain 68 degrees. So if it got below 68, the heating would turn on. And then if it got above 74, the cooling would turn on. Well, I've since had to kind of tweak some of those numbers a little bit. I actually dropped the heating down to 65 and I dropped the cooling down to 72 because I kept getting these nuisance complaints of it's too hot in here now, So again, it's like a whole mixture of problems. And, they're sometimes kind of hard to get through. But, I just do my best. I get everything back up and running as best as possible. Since I did this service call, it has been about 2 weeks, and I really haven't had any other complaints from the customer. So it's just a learning process. A lot of it stems from the fact that they have this energy management system that doesn't ideally work the way that I would prefer. I'd prefer to have just a conventional thermostat in there. I do like the idea of being able to log in and look on my phone. Like when I do see the service calls, like for instance, when I got this service call, the first thing I did was I opened up my phone, looked at the internet thermostats and just kind of looked at the temperatures in the building. And I was like, it didn't seem that bad, but there's always a possibility that there was a bad sensor or something like that. But when I looked at it, it was like the building wasn't too hot, So I made a few adjustments the day before I came out on this call. And, it seemed to be okay until I got there. So, again, I can't say that like this was the exact cause or that was the exact cause, but I know that I went in there, made a few adjustments, tweaked the AC, made it work a little bit better, and all is well. I really appreciate you guys making it to the end of the video as usual. It's very humbling to see all the support and comments and interaction that you guys have in the channel. So thank you so very much. Again, it's still a little difficult for me to understand that you guys actually want to watch these videos, but that's my own head messing with me. It's like an imposter syndrome thing or something like that. But anyways, I really do appreciate you. Thank you so very much. Remember to be kind to one another. I say this a lot, but I can't stress it enough. You never know what someone else is going through. Not justifying anybody being a jerk, and I know I keep saying the same thing, but it's so true. Sometimes someone could just be having the worst day of their life, and you may see it as them being rude, and while it essentially is being rude if they did something rude to you or something like that. But, you know, sometimes maybe they just need a little compassion. Sometimes maybe they just need a little kindness. You could make their day, right? So thank you very much. I really do appreciate you. If you haven't already, please consider subscribing to my channel. HVACRvideos.com is the website. There's merchandise available on there. There's several different ways to support the channel. The easiest of being watching the videos from beginning to end. Okay. The next way, PayPal, Patreon, YouTube channel memberships. There's links in the show notes of this video. And if you're interested in purchasing any tools, as usual, go to TrueTechTools.com. You can use my offer code BIGPICTURE. That will get you an 8% discount on a good majority of the items on their website. There's a few things it doesn't work on, but when you use my offer code, I get a small commission from that. So it's a great way to help support the channel. Again, I do appreciate you, and we will catch you on the next one, okay?